Let's look at this geometry problem. In the non-convex quadrilateral ABCD shown below, BCD is a right angle. Where is BCD? BCD. So this is a right angle. And AB equals 12. So this equals 12. BC equals 4. Where is BC? Here is 4. And CD equals 3. And AD equals 13. And it is asking what is the area of the quadrilateral ABCD. So there are a couple ways to think about it, but the bottom line is there's only one way to solve it. Because if you are familiar with Pythagorean triples, you would recognize that there's a triple that is 3, 4, and 5, right? And there's a triple of 5, 12, and 13. So all these 6 numbers, not all of them, but most of these numbers appear in this problem. So that will motivate you to think about right triangles. Then the rest of the work is straightforward. So let's assume you are not familiar with all the well-known Pythagorean triples. We can start from scratch, because the question is about the area of the quadrilateral ABCD, which is a very odd shape. What we are familiar with are triangles, or maybe squares or rectangles, something like that, right? Even a trapezoid. That's even better than this. So what does this look like? It doesn't look like anything. So then how do we calculate an area of a shape? So certainly, the quadrilateral formulas, like for the area for the square, or the area for the rectangles, or the trapezoid, wouldn't apply or directly apply here. So what may apply is this, because we know of one thing, a right angle. So that's this angle. So which may remind us that the area of a triangle may help. Then how do we calculate the area of a triangle? So the normal formula would be a half times the base times the height, right? So we can take any line segments as a base in this picture. We can take AB or AD or BC or any line segments. But the problem is about the height. Do we know anything about the height? Or is there any height drawn on this picture? Then this right triangle helps, because then that gives a base and a height, right? CD and BC are perpendicular to each other. Therefore, that may remind us to connect this line, BD, this line segment. Once we have this triangle completed, then this area, let's write here. So this area, the area of the triangle, actually the right triangle BCD is known. Why? Because we have a base, BC, we have a height, CD. This is perpendicular, right? A right angle. Therefore, that area equals a half times the base 4 times 3. That's 6. Good. And okay, let's check back the question that's asked. We want to know the area of the quadrilateral ABCD. Since we've already known the area of this triangle, then we just need to know the area of the triangle ABD. If somehow we know that, then it's done, right? We just take the difference, and that's the answer. Then how do we do that? 2 sides of this triangle is known, AB and AD. And again, we need to find a height. So where's the height? We have 12 here, we have 13 here. So don't forget, we have a 3, we have a 4. The good thing is that we want to know this length, the length of the line segment BD. because if we know the three sides of a triangle, then that's possible to calculate the area of it. Therefore, let's calculate the line segment BD, not AD, BD. So that will equal to, by Pythagorean formula, that equals to 4 square plus 3 square. So even if you don't know any other Pythagorean triples, you should still know this one, right? That equals to 5. Now we can see the Pythagorean triples of 5, 12, and 13. And we can justify that, right? So in order to justify that, we'll prove if that Pythagorean formula holds. So if 13 equals to 5 square plus 12 square. Is it like so? So that's 25 plus 144, right? That's 169. And then that's 13 square. No problem. So this is a right angle. So ABD, the triangle ABD, is a right triangle. Therefore, the area of this right triangle, so it's actually a right triangle, equals to a half times 12 times height, 5. So that equals to 6 times 5 equals to 30. And of course, the answer will be of the ABCD, the area of ABCD will equals to 30 minus 6. That's 24. So the answer is, where is it? B. And some students may wonder that why do you want to check this? So it's good to know some famous or well-known Pythagorean triples. But even if you don't know, how do you calculate this area? This area, SABD. So some formula may require you to calculate the angles, right? You want to know the angles A or these angles, right? So even if you calculate the angles, let's say you use the cosine formula to calculate the angle B, you still need to check these, right? Some students may know that for the cosine formula in a triangle, that is, let's take angle B, for example. In general, AD square equals to BD square plus AB square minus 2 times BD times AB, this is B, times cosine angle ABD. That's a general cosine law in any triangle with any angles, right? So you may apply even the sine formula to calculate this area. But either way, you want to know the angles, all right? Or for general triangle, you may want to do that. For example, if you know the length of the three sides, let's say this is A, B, C, right? You still want to draw a height, and then you apply the Pythagorean formula on the right, on the left right triangle and right triangle, and then you use some algebraic way to calculate the height. That's a generalization of this problem. So for this particular problem, all what you need to know are some well-known Pythagorean triples. That's so much for this problem. If you like this video, please subscribe and thumb up. If you have questions, please comment.